Okay, so you've already watched the number cubes video. You've now started looking at the introduction for Investigation 2 on page 149, and it gives us this first pattern. Okay, and you can see we have stage 1, stage 2, stage 3, stage 4, and you can see that we've already created our first table. Now, the first table that we've chosen to look at, and we're going to again use N for our stage number, and we're going to use T for our number of toothpicks, okay, is the total number of toothpicks. So as I'm working this, again, I want to be able to say, how many toothpicks are in stage 1? So we don't want to go, oh, look, plus 3, plus 3, plus 3. We want to go, how do we get from 1 to 4, from 2 to 7? And like we talked about in the first video, we want to start with the basics. So to get from 1 to 4, I know that I could add 3. And I also know that I could multiply by 4. So I'm going to check my simplest one first. 1 plus 3 is 4. 2 plus 3, not 7. 3 plus 3, not 6. 4 plus 3, not 13. Okay, it's definitely not that one. So let's try times 4. 1 times 4 is 4. 2 times 4 is not 7. 3 times 4 is not 10. Okay, so it's definitely not that either. Now, we did say, if you're going and you've done the simple addition and you've done the simple multiplication, then we're going to have what's called a two-step equation. So we're probably going to have to multiply first and then either add or subtract. And we found a shortcut before, or we talked about a shortcut before. Remember I said that this was plus 3? Well, the really cool thing about these patterns is that is going to end up being the number that we need to multiply by. So you're going to tell me that 1 times 3 is obviously not 4. Well, I do know that. Okay. That we did say it was going to take a second step. So to get 1 times 3 equals 3, to get to 4, we'd have to add 1. So let's see, 2 times 3 is 6, plus 1 is 7. Looking good so far. 3 times 3 is 9, plus 1 is 10. 4 times 3 is 12, plus 1 is 13. 5 times 3 is 15, plus 1 is 16. So that really wasn't so bad, as long as you remember that if it's not basic addition or not basic multiplication, chances are the difference from one output to the next is going to be what you're multiplying by. Now, of course, this is not an algebraic equation. We don't want to turn in our rule in this format. So we want to say that the output, or T for total number of toothpicks, is equal to the stage number times 3. But again, that's not very algebraic in the format. So we want to do 3 times n plus 1. So this would be the rule for finding the total number of toothpicks. Now, of course, that's not the only variable we could look at here. We've got a lot of different choices. And part B wanted you to, or no, part A, sorry, wanted you to look at the number of squares in this pattern. So if I come back up here, we're going to have n equal our stage number, and we're going to have s equal the number of squares. Now notice I'm giving you my variable and a definition in my function table, so there's no confusion. So in stage 1, there's 1 square. In stage 2, oh, this is tough, there's 2 squares. Stage 3 is 3, and stage 4 is 4. So that means that the number of squares is equal to the stage number. So if I want stage 23, there's going to be 23 squares. That's really simple. Doesn't get too much easier than that. So that was 1A. Now 1B wanted you to have looked at the vertical toothpicks. So I'm going to get this other one out of my way so that we can come back and look at it separately. So now again, we're going to have our stage number. But now we're going to have V for the vertical toothpicks. I'm running out of room, so I'm just going to abbreviate here. Now, just to make sure you remember, vertical means going up and down. So in stage 1, there's 2 vertical toothpicks. And in stage 3, now be careful, there's only 3. In stage 2, there's only 3 vertical toothpicks. And in stage 3, there's 1, 2, 3, 4. In stage 4, there's 1, 2, 3, 4, 5. So it looks like this rule is not going to be too tricky to figure out either, because I'm thinking it's going to be +1. But let's check. 1 + 1 is 2, 2 + 1 is 3, 3 + 1 is 4, 4 + 1 is 5. Now, of course, that works, but that's not a very algebraic rule. So we need to change that. So our vertical number of toothpicks is going to be equal to the stage number +1. That is an algebraic rule. So that works great for 1B. And it makes sense that that would be what the rule was. Actually, that would be 2B, because in 1B you're only doing the table. In 2C, you've been asked to figure out the number of horizontal toothpicks. So we're going to have N for the stage number again, and then we're going to have H for horizontal toothpicks. So again, horizontal is now going in the opposite direction. So let's get 2B out of our way. And you don't have to fold yours, but I think it's easier for you to follow if it's right underneath. So we have our 4 stages. Now we're talking horizontal. Stage 1 has 2. Stage 3 has 1, 2, 3, 4. Stage 3 has 1, 2, 3, 4, 5, 6. And stage 4 has 1, 2, 3, 4, 5, 6, 7, 8. So in looking at our rule, we'll start with the basics again. To get from 1 to 2, it would be +1 or times 2. So 1 + 1 is 2, but 2 + 1 is 3. And 3 + 1 is 4, and 4 + 1 is 5. So obviously it can't be +1. Let's try times 2. So 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and 4 times 2 is 8. So we found our rule, but again it needs to be written algebraically. So we're going to do H for horizontal toothpicks is equal to, and again, we don't want to write N times 2. That's not very algebraic. We want to put the number in front of the variable. So the number of horizontal toothpicks is equal to 2 times the stage number. The last one we need to look at is 2D. This one's tricky, and you may have had trouble when you were trying to figure this out in your table for step 1. Pardon me. Okay, so in part D, we've been asked to do our stage number and the number of rectangles. Now, we're going to have to do a little bit of thinking about this. Let me fill in my stages. Now, in order to get this question correct, you have to remember that a square is a type of rectangle. So we need to make sure that we are still looking at all of our shapes. So here for stage 1, we have a square, which would be 1 rectangle. For stage 2, we have 1, 2, but we also have this outer one, which is 3. For stage 3, we have 1, 2, 3 that are 1 square each. Then we have 1, 2 that are 2 squares each, so that's now 5. And then we have the big one, so that's 6. For stage 4, we have the 4 single ones. We have 1, 2, 3 that are 2. We have 1, 2 that are 3, and then we have 1 that's 4. So total 7 and 3 is 10. So that was kind of tricky in and of itself. Now we've got to find the rule. This might confuse us a little bit, because obviously we could add 1 or multiply by 1, but this is, or add 0 or multiply by 1, but 1 plus 0 is 1, but 2 plus 0 is not that, and we're not working for our others. And 2 times 1 is not 3. So this one gets a bit trickier. So as we look at this, I go from 1 to 2 to 3 to 4. Oh, that's not going to help me either. So this is definitely multi-stage, but it's not going to be a basic multiplication one. Let's think about this for a second. There were, in stage 1, there was 1 regular square. In stage 2, there was 2 1 squares and 1 2 square. In stage 3, we had 3 1 squares, 2 2 squares, and 1 3 square. And then in stage 4, we said we had 4 1 squares, 3 2 square, 2 3 square, and 1 4 square. This one's pretty tricky. Let's see. If we do, for stage 1, it was 1. For stage 2, stage 2, it can't be plus 1. But it could be, I wonder if we added 1 to the stage number,